Question 9.3 is asking us to show that the concavity of h changes at x equals a half. I would recommend that you go and have a look at the videos on concavity that have been done to get a greater understanding of this. But basically, what it's asking us to show is that at a half, either this graph is going from concave down to concave up, and that would happen over there at the point of inflection, or it's going from concave up to concave down. Now notice what I said. That happens at the point of inflection. So there's a couple of ways we could approach this. We could have a look at what the second derivative looks like just before a half and what the second derivative looks like just after a half, and see if there's a sign change there. If there is, the concavity would have changed. That's one way of looking at it. Another way of looking at it is to simply go and show that at a half we have a point of inflection. So what I'm going to do here is go and look at the first derivative of this function, which is going to be minus 3x squared plus 3x plus 6. I'm then going to go and have a look at the second derivative of this function, which is going to be minus 6x plus 3. I'm going to force the second derivative to equal 0, because when your second derivative equals 0, that is where your point of inflection happens. And that is where your concavity is going to change. So let's go and solve this equation. And we'll get 6x equals 3, x equals a half. And so therefore we can conclude that the concavity changes at x equals a half. Because at x equals a half, we've got a point of inflection. Just as a matter of interest, since we have a negative in front of our x cubed graph over here, we can see how that concavity is in fact going to change, because our graph is going to look like this one over here. And we can see that before a half it was actually concave up, and after a half it's going to be concave down. Question 9.4 now wants us to explain the significance of that change in question 9.3 with respect to h. Well, it's significant in that at x equals a half, there is a point of inflection.